Let's go one level down to more detail about the indirect effects of lightning itself. There are basically three different effects. There is an impact on overhead lines. There is a rise in ground potential whenever a lightning occurs. And obviously, when there is a lightning, because tremendous amount of energy is being generated spontaneously in kind of a spike surge form, it generates electromagnetic radiation. Now, the impact on overhead lines means that the heat generated because of the lighting basically destroys lines. The lines that are destroyed, they are basically melted. And this tremendous temperature affects the equipment. So not only the lines, but the heat goes through the lines and affects the equipment connected to the lines. That's the impact on overhead lines. The rise in ground potential is completely different, and it's very, very dangerous to PV systems. If the ground suddenly gets voltage, high voltage potential rather than being zero, that means the entire potential of the PV system is not referred to zero anymore, but it refers to some level of voltage. So the system sees different reference condition, destroys its performances, destroys the equipment, because everything is basically referred to zero. The electromagnetic radiation is something completely different. The lightning itself should be considered as a big antenna. Antenna that its height is approximately 1 kilometer. And the amount of voltage in this running in this antenna and the energy that's spread out from this antenna, it's basically a transmitting antenna. It's an area of kilovolts per meter. And remember, the length of the lightning sometimes go up to 1 kilometer. So in this 1 kilometer long antenna, we have kilovolts being transmitted out. That changed the environment around the PV system. And again, there is this zero reference in the environment.